Hello friends, I am Shruti Joshi from Shri Gajanan Maharaj Shikshan Prasarak Mandal's Jnanvilas College of Pharmacy, Dudurgaon, PCMC, Pune. Today I am going to deliver a PowerPoint presentation lecture from Pharmaceutical Chemistry 1 on the topic Expectorants, Emetics and Respiratory Stimulants. Learning outcomes for this topic are: at the end of this topic, learners will be able to explain the concept of expectorants, explain the concept of emetics, describe respiratory stimulants, and explain monographs of few expectorants, emetics, and respiratory stimulants. Now we are going to learn what are expectorants. Expectorants are the drugs that remove sputum from the respiratory tract. These drugs either increase the fluidity or reduce the viscosity of sputum or increase the volume of fluids that are to be expelled from the respiratory tract by coughing. These are used orally to stimulate the flow of respiratory tract secretions. The rationale is that this facilitated flow allows ciliary motion and coughing to move the loosened material toward the pharynx more easily. Expectorants are used in the treatment of respiratory disorders in which secretions are purulent, it means consisting of pus, viscid, it means sticky, or excessive, more than necessary. Expectorants are classified according to their mechanism of action into two main categories, that is, sedative type and stimulant type. First one, sedative type. These are stomach irritants. They produce their effect through stimulation of gastric reflexes. Example, bitter drugs like Ipecac, Senega, Indian squill, or compounds like antimony potassium tartrate, ammonium chloride, sodium citrate, potassium iodide, etc. While stimulant type expectorants are the types of drugs bring about stimulation of the secretory cells of the respiratory tract directly or indirectly. Since it stimulates secretion, more fluid is produced in the respiratory tract and sputum gets diluted. Example, terpenoid oils like eucalyptus, lemon, anise, etc. Now, emetics. Emetics are defined as the drugs which are used to cause emesis, that is, vomiting. Emetics are generally used in the treatment of different poisoning caused due to ingestion of poison or toxic materials. They produce their action directly by stimulating chemoreceptor trigger zone or by directly irritating intestinal mucosa. Some inorganic compounds act directly by stimulating secretions of respiratory tract. Emetics are added in cough syrup preparations. Example, sodium chloride, antimony potassium tartrate. Reflection spot. Dear guys, please look at the question. Think and write your answers in your notebooks. Which part of nervous system is responsible for vomiting? Okay, start. I hope you have written your answers in your notebook. Cerebral centers affecting vomiting. Vomiting, also called as emesis, the forcible ejection of stomach contents from the mouth, like nausea, controlled by two distinct brain centers, the vomiting center and the chemoreceptor trigger zone, both located in the medulla oblongata. The vomiting centers initiates and controls the act of emesis, which involves a series of contractions of the smooth muscles lining at the digestive tract. These contractions begin at the small intestine and move successfully through the stomach move successfully through the stomach and the esophagus until the stomach's contents are forced out the mouth. The vomiting center responds directly to stimuli from various parts of the body that may be stressed or diseased. The chemoreceptor trigger zone, by contrast, is stimulated by many toxins and drugs. Activation of this brain region stimulates the vomiting center, which initiates emesis in an effort to rid the body of the toxin. Respiratory stimulants. These are agents belong to the class known as central nervous system stimulants or analeptics. Respiratory stimulants increase pulmonary ventilation by their effects on the depth and rate of respiration. They act directly by stimulating the respiratory center in the medulla or indirectly by their effects on the carotid body. The pH or hydrogen ion concentration of blood and various chemicals which alter the pH also affect respiration through chemoreceptor trigger zone. Inorganic compounds act as respiratory stimulant by reflex mechanism. The epithelial cells of trachea, bronchial, and bronchiole get stimulated by irritation of drugs. Respiratory stimulants. Gaseous ammonia is a reflex stimulant for the medullary respiratory and vasomotor centers. Dilute ammonia solution, ammonical salts like ammonium carbonate, and preparations such as aromatic spirit of ammonia are in general considered as respiratory stimulants because they give off ammonia gas which irritates respiratory tract. Some important inorganic agents used as expectorants, emetics, and respiratory stimulants are as follows. First one, ammonium chloride. Molecular formula NH4Cl. Its preparation, commercially it is prepared by the interaction of ammonia gas with hydrochloric acid. The solution is evaporated to dryness. Properties. Ammonium chloride occurs as a white or colorless, crystalline, or a coarse powder. It is almost odorless and has a cooling saline taste. It is slightly hygroscopic, very soluble in water, sparingly soluble in alcohol, but freely soluble in glycerin. Freshly prepared aqueous solutions are neutral to litmus but become quickly acidic on standing due to hydrolysis. It is incompatible with alkalis, carbonates of alkaline earths, and lead salts. Action and uses of ammonium chloride. It acts as a mild expectorant and diaphoretic when administered in small doses. It is also used in the treatment of urinary tract infections as mild acidosis is produced when administered orally. It has been given to increase diuretic effect of mercurial diuretics. It acts in maintaining acid-base equilibrium of body fluids, retention of sodium ion, and replace chloride loss during vomiting or severe sweating. It is assayed by Wollard's method based on precipitation titration, that is urgentimetry, also can be assayed by acid-base titration. It should be stored in tightly closed containers. Then second, ammonium acetate CH3COONH4. Properties. It is colorless crystals or crystalline masses and deliquescent, that is, it tends to absorb moisture from air and dissolves in it. It gives the smell of acetic acid and it is very soluble in water and alcohol. Ammonium acetate has slight diaphoretic, that is, sweating heavily action. It is used in the form of dilute solution as mild expectorant and diuretic. The action is due to ammonium ions as that of ammonium chloride. Next, ammonium carbonate NH4CO3. Synonym, ammonium sesquicarbonate, cell volatile, Preston salt, Baker's ammonia. It is salt of variable composition of ammonium bicarbonate and ammonium carbonate. It contains equivalent of not less than 30% of NH3. Ammonium carbonate occurs as a white powder or a white translucent crystalline material having a strong odor of ammonia. It is volatile even at room temperature. It is very soluble in water and sparingly in alcohol. On exposure to air, it loses ammonia and carbon dioxide, becoming opaque, and finally, it is converted into a white powder of ammonium bicarbonate. Uses: it acts as a respiratory stimulant. It loses ammonia, which is reflex stimulant for the medullary, respiratory, and vasomotor centers, probably acting through irritation of the trigeminal nerve. It has also been used as an expectorant. Then antimony potassium tartrate, C4H4KO7SB. Synonym: tartaremetic, tartrated antimony. Properties: it occurs as a colorless, odorless, crystalline, or granular powder with sweetish taste. It effloresces on exposure to air. It is soluble in water and glycerol and insoluble in alcohol, chloroform, ether. Uses: it acts as an expectorant emetic due to its irritant action on mucosa. Its rational use is in the treatment of schistomiasis. It is also useful in the treatment of leishmaniasis. The drug has central depressant action and hence is not suitable as general purpose emetic. Incompatibility: it is incompatible with acids and alkalis, salts of heavy metals, albumin, soap, and tannins. It should be stored in airtight containers. Then potassium iodide, Ki. It occurs as a odorless, colorless, transparent, or somewhat opaque crystals or white granular powder with slightly bitter saline taste. It is soluble in water, alcohol, acetone, and glycerol. It is stable in dry air but somewhat deliquescent in moist air. Its aqueous solution is neutral or faintly alkaline and become yellowish in color on exposure to air. Potassium iodide has been used as an expectorant in the belief that bronchial secretion is increased by reflex stimulation of the gastric mucosa. It is used for the prophylaxis and treatment of simple goiter, then pre-operative treatment of thyroidosis, then treatment of cutaneous lymphatic sporotrichosis, then pediatric use should be avoided. Airtight, should be stored in airtight containers protected from light, and it is incompatible with salts of iron, bismuth, copper, lead, and mercury. Thank you, friends. Thank you so much.